All right, guys, today we're going to review a little bit about monomials. So ideally, we're going to get to polynomials and operations with polynomials this week, but let's review what a monomial is. So any number, variable, or product thereof is a monomial. So it doesn't matter if you have 7, or if you have x, even 7x. Those are all monomials. It's a single product of numbers and variables. We could even have something like that's a monomial, even if you stick that on it, or that again. Unless you've got a plus sign in there, unless you have a plus sign, a subtraction, not just a negative, a subtraction, or an equal sign, it's one thing. So monomials separated by addition, subtraction, or equality are, there's more than one of them. But if it's just multiplied together, just stuck next to each other, that's one monomial. Let's review our rules real quick. Okay. So the product rule. What happens whenever we multiply two monomials with the same base? Let's say a to the n times a to the m. So notice a and a, they're the same. The base must be the same in order to do anything with them. If we're multiplying them, then we're going to add the exponents. That's a to the n plus n. Let me get a little bit of space here. Okay. A to the n plus m. We add their exponents. For example, if we have a squared times a cubed, that's going to be 2 plus 3, so that's a to the 5th. The base does not change. Let's say we have power. So we have a to the x to the a power. I'm going to raise that to the b power. Whenever we raise an exponent to an exponent, we multiply those exponents. So notice again, the base is the same. The product of the exponents is what we need. So a raised to the b will be a times b. Example, x squared times x cubed. Sorry, just did the product. Raise the third power. So this is what it would look like. So x squared cubed is what we're talking about. That means we're going to multiply our exponents here. That's x to the 6th power. Quotient rule. Remember, quotient means division. So if we have x to the a power over x to the b power. Again, your bases must be the same. Remember, multiplication and division, they're the same operation, basically. So it shouldn't be any surprise that when we add with the product, we're going to subtract with the quotient, a minus b. Example, let's do x to the 6th divided by x squared. So same base, x, and then we're going to do 6 minus 2, which is 4. We subtract the exponents. Now, there's a couple ways you can see a negative exponent. Let's say we have a to the b power raised to negative 1. That would be the same as having a to the negative b power. Now, it doesn't matter what your base is. It could be x, a, z, y, whatever. So I'm just using random things here. It doesn't matter. Now, these are the same thing, and we express that by using the reciprocal. So we're going to reciprocate it. Instead of a to the negative b, it's going to be 1 over a to the b. We're using that negative, so it's going to not be there anymore. Otherwise, you just keep flipping back and forth. All right, so if we have x to the negative 2 power, let's say, that's 1 over x squared. Finally, we have the 0 exponent rule. So anything other than 0, so let's go with x, to the 0 power, or, to the x squared to 0, whatever, anything to the 0 power is, do you remember, 1. The one exception, though, 0 to the 0 power. Now what that is undefined. We can't do it to get to calculus. But yeah, so as far as you're concerned, 0 raised to the 0 power does not exist. Once you get to calculus, then you can see, oh, hey, it's 1, or it's infinity, or it's negative infinity, or it's 5. It could be all kinds of different things. But as far as algebra is concerned, you can't do it. Just like dividing by 0, you can't do it to get to calculus. So let's say we have x squared to the 0 power. It doesn't matter what's in here. It could be x squared, it could be x, it could be x cubed, it could be an elephant, it could be your mom. It doesn't matter. Anything to the 0 power other than 0 is 1. Done. These are the rules. You need to know your rules. You need to be able to apply your rules. You should already know your rules. We've gone over this before this year. All right, let's apply them. So this first, we look at what's going on here. 5x squared times negative 7x to the 6. That's not a minus 7x to the 6 because we're multiplying by, you can't multiply by subtraction. You multiply by negative 7. So multiply your like things together. 5 times a negative 7, that's negative 35. X squared times x to the 6. We're multiplying, same base, the base isn't changing. We're multiplying, 2 plus 6 is 8. That's our product rule. There's nothing else we can do. There's nothing like here that we can simplify. Moving on. You read this next one, we got this in parentheses, so this whole thing, negative 2a cubed b squared. So that whole thing is being squared. Times 8ab to the 9th. So you have to remember your order of operations. They apply for doing basic arithmetic, whether you're dealing with natural numbers, integers, rationals, complex, or even polynomials. Please excuse my dear Aunt Sally, if you will. So parentheses first, I'm looking in here, there's absolutely nothing I can do with that. Moving on, exponents. So I need to square this thing before I multiply. So let's do it. So what kind of thing is this? This is a monomial. Notice there's no plus sign, there's no minus sign, there's no equal sign. So this is a monomial. That means we can take a little shortcut. We can square each individual piece. However, if we have anything other than a monomial, you better write it out. Remember, what does squaring something mean? Multiply it by itself. So if you do have a plus sign in there, go ahead and write it out and use your distributive property. If we don't, so I'm just going to square it piece by piece. Negative 2 squared is 4. A cubed squared, power rule. A cubed to the second power is a to the 6th. B to the first squared is b squared. Now we're still multiplying by 8ab to the 9th. So notice we still have things we can put together, so we are not done. We can combine the 4 and the 8. What's 4 times 8? 32. A to the 6th times a, well, that's a to the 1st, understood right there. That's a to the 7th. B squared times b to the 9th, well, 2 plus 9 is 11. Checking in here, nothing else we can do, done. All right, so in order to organize these things, they can get a bit messy when you're doing it with quotients, so I like to organize them. So we have this quotient and a subtraction. We've got two things again, but we have to divide before we can subtract. So I see some numbers up in here, put some numbers down there. I see some m's, and put some m's. You might have some more m's on the other side. You'd stick all the m's together. We only have one set of m's, so we're good. Now, we also group these in the denominator with the same types of things in the numerator. So that's a 3. That's an m squared. That's an n understood first power. So I'm just writing out the quotient in a little bit of more organized way. So 54 divided by 3, that's 18. M to the 6 divided by m squared. When we're dividing, we subtract our exponents. 6 minus 2 is 4, n to the 4th power. N to the 4th divided by n to the understood 1, so that's n to the 3rd. And we still have a subtraction. Excuse me, we've got 10 m to the 4th in cubes. So let's look at what we have. We have 18 m to the 4th n cubes minus 10 m to the 4th n cubes. Think about these as like your object, your item, your units even. You've got 18 things minus 10 things. So if you have 18 dogs and I kill 10 of your dogs, you have 8 dogs left. Dogs, they're still dogs, right? It's not going to change what this is. So 18 minus 10 is 8. 8 what? 8 of these things. Our things here is m to the 4th n cubes. Notice they are the same thing. If they're not, you can't do anything. So for example, if this were just n, it's m to the 4th n cubed and m to the 4th n. Those are not like terms. It's saying 18 dogs and I killed 10 of your cats. Can't do anything. So you just leave it alone. But since we do have like terms, we can combine them, and we must. All right, let's look at this next one. We're multiplying here. It's going to be 20. 4 plus a negative 7. So that's k to the negative 3. That's not incorrect, but it's not done. We cannot leave a negative exponent, ever. That's not simplified. What happens with the negative exponent? Well, we reciprocate it. So I'm going to do it this way. So we basically have 20 times 1 over k cubed. And of course, you can simplify that. How do we multiply a fraction? Numerator times numerator, denominator times denominator. And we're done. You can also think about the negative sign as its location. It's going to change location. If it was in the numerator, it's going to the denominator. If it was negative in the denominator, it's going to go to the numerator. And once we move our monomial or our term or whatever part it may be, it's going to not be negative anymore. We use the negative. Or so here again we have a squared, an exponent, and a multiplication, a product. So I'm going to do the exponent first. Again, nothing inside the parentheses that we can simplify. And even if we did, we wouldn't have to do that first. A lot of times it's easier if you do though. So that's 2/3 squared. So 2 squared is 4, 3 squared is 9. R squared, squared. 2 times 2 is 4, so R to the 4th. S to the 7th squared. 7 times 2 is 14. Okay, we took care of that exponent. Now we still need to do this product here. We still have to do this multiplication. 4/9 times 1/6. Use your calculator. That's 2 27ths. r to the 4th times r cubed. That's r to the 7th. S to the 14th times s. Remember, that's an understood 1 right there, so that's s to the 15th. Now, it's perfectly acceptable for you to put these in the middle or the numerator. Either way, same thing. Do not put them in the denominator, though. That would be wrong. So as long as they're in the numerator or the middle, it's okay. I prefer the numerator. I prefer them written like this and not like this. So just get in the habit of putting them in the numerator and you'll be safe. Let's look at this one. So excuse my dear Aunt Sally. Oh, hey, I could simplify this parentheses. So you can do that first, but you do not have to. It's entirely your choice. I'm going to. It's actually easier that way. What's 14 divided by 7? 2. W to the 12th over W cubed. W to the 9th. This entire thing is being reciprocated. Look at that. It's the -1 power. So all we have to do is reciprocate that, and we're done. That's it. Nothing more to do there. Okay, let's look at the next one. Okay, we've got division again. So if you're really fluent with these, you do not have to break it up like this, but it's a good practice if you're having trouble seeing what's going on. Numbers are going in here. I'm gonna put some X's in here. And I'll show you a shortcut after we do this. So 15 over 24. Simplify that, 5/8. X to the 10 minus, so x to the 10 divided by x to the 12th, that's subtraction, so that's x to the -2. Y to the 4th over y cubed, that's y. 4 minus 3 is 1. So remember, we cannot leave a negative exponent. So we're going to reciprocate that, so it's going to be, I'll write it out long ways, and then I'll show you the shortcut. So that y, it's in the top. It's going to stay in the top. Okay. Times 1 over x squared. So the x squared is going to go on the bottom, and the 5y is going to be on top. And there we go. Okay, shortcut. From right here, you can pretty much be done. So right here, again, the only thing I'm going to change is this. So this is 5, 8. So if you have it nice and separate like this, which one's bigger, 10 or 12? 12. So you're going to do the 12 minus the 10, it's going to be 2, and it's going to go where the 12 is, the bigger number. Well, that's in the bottom. 4 and 3, which one's bigger? The 4. So it's going to be, our answer is going to be in the top. So 4 minus 3 is 1, so it's y to the 1. Done. So it's a little shortcut you can take there. Don't have to, you can do all the work, it's perfectly fine by me. But if you want to save yourself some time and effort, you can just think about where does my answer need to go, which place has the bigger exponent. And that'll get you. So again, I'm going to simplify before I raise it to a power. C over c squared, that's understood 1, 1 minus 2. Which one's bigger? The squared. There's going to be a c on the bottom. That's just going to stay that 1 on top. -3c, all that raised to the 4th power. So that's 4. That's not. Every single hour today. 1 to the 4th power was 4. Didn't fail. It's 1 times 1 times 1 times 1. It's 1 still. So 1 to the 4th power is 1 over c to the 4th power times. -3 to the 4th power. Well, use a calculator if you need to. That's 9 times 9 is 81. Yeah, use calculator. C to the 4th is C to the 4th. So again, you can organize it if you want to. 81, we got that times 1 right there. I got C to the 4th over here. I got C to the 4th down here. 81 times 1 is 81. Which one's bigger? Oh, they're the same, so it's going to cancel out. Why does it cancel out? Well, if we do it, C to the 4th minus 4, that's 4 minus 4 is 0, so that's C to the 0 power. What's C to the 0 power? 1. Anything to the 0 power other than 0 is 1. So that's 81 times 1, which is 81. And that's why they're going to cancel each other out right there, because they're going to make a 1. And anything times 1 is itself. All right. Let me throw this on here. So if we have multiple monomials, we call it a polynomial, no matter how many there are. So if you're adding and subtracting monomials, it's called a polynomial. Many monomials. Now we have special names for the polynomials. The highest exponent is called the degree of the polynomial. Yes, this should be a review. Now in standard form, so that's going to be descending, if I spelled that right, I hope, order. So for example, you could have some number a sub n times x to the n plus a sub n minus 1 x to n minus 1. So the power is getting smaller by 1 each time, or, you don't have, if it's a 5th power, you don't have a 4th power term, you go to the cube, you just put it in order. Plus dot, 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 plus a constant, a naught. Whatever, that's your constant term. So you just put it in order. It's got to be descending, going down. So your highest exponent first, then your next highest, and your next highest, and your next highest. That is standard form. Just like for a quadratic, so specifically a quadratic is ax squared plus bx plus c. Second power, that's the highest. X, the first power, that's the next highest. No power at all, so 0 power, if you will. That's your constant, that's last. So we got a few special names here. If we have a 0 degree, that's just a number. That's called a constant. First degree, that's like x, y equals x, that's linear. Second degree, that is a quadratic. Third degree is a cubic. Now, that's as far as I'm really concerned, but these two do have special names. That's a quartic and a quintic. I'm not too terribly worried about that. In fact, don't even worry about them. As long as you get up to cubic, we're good. So don't worry about the special names here. You can call it 4th degree, you can call it 5th degree. You can call this a 3rd degree, a 2nd degree, and a 1st degree polynomial as well. Constant, you just call it constant. But a linear could be named a 1st degree polynomial. It's not wrong. I'd take it. Now, the number of terms, you should know monomial is 1 term. Binomial is 2 terms. Trinomial, why did I capitalize that? I don't know, no particular reason. There's 3 of them. And then if there's more than 3 of them, we just call it a polynomial. Like, okay, we don't have special names. Okay, so really the question was mainly, is it a monomial or is it not a monomial? Because that's, if it's not a monomial and you're multiplying the thing, then you're going to be using the distributive property. Okay. Write the polynomials in standard form. Once that goes. All right, I'm back. So write the polynomials in standard form. So again, standard form, descending order. So we got some k's going on. What's the highest degree here? A 5. So that's what I'm going to start with. Negative k to the 5th. That's a 5. Let me see if I have any 4s. I do not, so I'm going to go to the 3s. Minus, this the sign goes with it, so minus 3k cubed. Look for some squares. I got a positive 1/4 of them. Any linear terms? Yep, 8k's positive. And then my constant, -1. Descending order. That's standard form. Moving on. And of course, you have to have like terms combined. If we look at this next one, you have to decide, or you have to be told, which term is your variable. I'm going to go with a as my variable here. So we're going to pretend b is just a number. Okay, so the a is all I'm looking at. So this is going to be 4a cubed because I don't have anything. This is a third degree polynomial cubic. So that's 4a cubed. Do I have any a squareds? I have 18 b squared a squareds. So plus 18 a squared b squared. Again, b is just a number. Plus 7ab's. It is to the first power minus b squared. Why is the b squared last? Because it's just a number. We called a our variable, so we let b just be a number. It doesn't have any bearing on our degree. It could be b to the 5 million, and we still put it last because a is our variable. Just like if we had 2 to the 5 million, it's just some number, big number, it's a number nonetheless. Over here, I'm going to go with x's because, yeah, I like x's better. We're going to call x our variable. Y is just a constant. So let's see, I have x squared, x cubed. So let's go with x cubed first. I have 9x cubed y minus x squared plus 5xy squared. And then I don't have any constant. Oh, wait. Hang on. I wrote that wrong. I said it, but I didn't write it. 5xy squared. And then constants. So I have minus y to the 4th plus 2. So I'm just write like that one out. Again, y is just a number, so don't even worry about which way it goes. There. You could have also written this with y's as your variable. So you'd have gone y to the 4th. Don't have any y cubes. You've gotten y squared, y, the 2 constants. Either way is fine. It is. If they don't tell you which one your variable is, pick one. I don't like these. These aren't really applicable to much of anything other than pure math. So partial differential equation, you get there that you won't, most likely. But for our purposes, these are pure math. So whatever. Just pick one. So let's name these things just a couple of them. So the degree, the number of terms. How many terms does this have? 1, 2. What's the degree? 1. So that's linear binomial. Linear binomial. What's the degree here? 5. So that's a quintic. Again, I don't care. Fifth degree. I'm gonna call it fifth degree. How many terms do we have? 3 of them. Fifth degree trinomial. Trinomial. Jesus, I can't ask that. Trinomial. There we go. We got 1, there's a minus sign, 2, there's a plus sign, 3. That's a constant monomial. You get the idea. This is cubic. 1, 2, 3, 4 terms, so it's a cubic polynomial. Second degree, so that's quadratic trinomial. Fourth degree, so that's quartic, or we'll just call it fourth degree. How many terms is it? 1 monomial. Notice it's not something minus 3 halves x to the fourth, it's just negative 3 halves x to the fourth. So it's only 1 term there. And I think, yep, that's it for this video. See you in the next one with operations.